This video will cover the assembly and use of the Arclight pipe cutter. First, you're going to mount the pipe cutter flush up against the gantry. Have your gantry positioned so it's about 2 to 2.5 feet back from the front end of the table. Next, make sure the pipe cutter is flush up against the gantry and lock it in place with the 5/16 bolts through the 2 holes that will match up on either side. Then remove your torch from the magnets, set it up on top, and we're going to remove the magnets from the torch holder. Set these magnets aside when you're done. Next, you're going to attach the magnets to the overhead arm extension. Then you're going to attach the overhead arm in place of where the magnet sat using the 2 larger holes that are on the mounting plate. You'll use your 5/16 bolts. Now, you have the ability to adjust this up and down in different positions. Your choice of position will depend on the size of pipe you're cutting. You just always want to ensure that you have enough clearance to be able to have the Z-axis move up 2 inches in between cuts without hitting the stops at the top of the travel. Now you're going to place your pipe that you're going to be cutting on the pipe cutter. Slide it through the belt, ensuring that the belt is sitting flat and it's not twisted. Once you get it in position, have it set so the pipe is contacting both sets of bearings on the end. Then push down on the motor to give tension to the belt and lock it in position. Now at this point, the pipe should be setting so that it's contacting both sets of bearings on the end and contacting the support bearings. Now all of these bearings are fully adjustable, so if you find that one set isn't quite touching, you can make small adjustments. So the support bearings can be fully adjusted up and down and to the left and right. So you're going to line your pipe up so that it's even with the axis of the pipe cutter. Next, you're going to jog or manually position your X-axis and Z-axis over top of the pipe and attach your pipe or your torch to the pipe cutter head with the magnets. Then you're going to position your torch over top of the center of the pipe so that it's dead vertical. Lastly, you're going to open up the control cabinet. Make sure the motor power is off, hitting red button so the green light goes out. Once that is done, you can remove the Y-axis motor plug and replace it with the motor plug from the pipe cutter. And once that's done, those are securely set. So now that you've swapped out the motor plugs, your first step after powering up your control box is going to be to load up your Mach 3. So you're going to click on your Mach 3 loader and it's going to pull up your profile. And you're going to have these same profiles. The profile we want is the Arclight tube cutter profile. Okay, if we double click on this or highlight it and click OK, this will pull up the correct profile and parameters that will allow us to use the pipe cutter correctly. So once you got this powered up, first you're going to hit the reset button, pull it out of reset. Now you're going to be able to jog your machine. Now your x-axis and your z-axis will jog exactly the same as before. However, when you jog your y-axis, if you hit the up button, it will rotate the pipe towards you. If you hit the down button, it will rotate the pipe away from you. So this is essentially, rather than moving the gantry away from you or towards you, it's rotating the pipe instead. So it's the same process. Now the first thing that we need to set up with the pipe cutter is to get the proper rotation or the proper steps per inch so that the pipe moves the correct distance. If you want a 1-inch cut, it will move 1 inch. If you want to cut off the pipe exactly, you'll be able to move the exact circumference of the pipe. So the first thing we need to do is know the circumference of the pipe that we're working with. So this being a 3-inch pipe, it's 9.42 inches in circumference. So what we're going to be doing is making adjustments in your configure menu. If you go to the motor tuning, you'll see right now we're on the y-axis. If I swap it to the x-axis, I'm going to swap it to the y-axis. We're going to be making adjustments to this number right here, the steps per inch. That will allow us to get the pipe to rotate the correct distance. So to do that, okay, I'm going to cancel out of this. The first thing we need to do is to go into our diagnostics menu, okay, and we're going to set up our steps, okay, to move 9.42 inches. Normally, this number is set to 1/100 of an inch. So when I hit the control button and hit a jog arrow, I move 1/100 of an inch. Okay. This time we're going to set it up to move 9.42 inches, or whatever distance the circumference of the pipe is you're working with. Okay. So once we've had this step set up to be the circumference of our pipe, go back to the program run menu, and the next step is going to be to mark a line or a dot right at the torch. So we're going to jog our torch down to the pipe so it's right over top of the pipe and make a mark. I usually just use a permanent marker. I just make a small little dash right at the center so that I can use that as my spot to tell if I'm rotating the pipe the correct distance. So now once I've made that mark, what I'm going to do is I'm going to hit the control button, hold it down, and then I'm going to hit the up arrow. And what's going to happen is that the pipe is going to start rotating towards me, and you'll see it rotating. It's going to go pretty much a full rotation. So now you can increase the speed of this rotation by using the override, the feed rate override. If you bump that up, it'll increase the speed. So we've cut out the middle. So as you can see, on this one, we didn't quite we went a little bit past the line. So the next step is you're going to hold the control button and hit the down arrow so that the pipe then goes back to the original position. So it's going to rotate away from us. Okay, this is really important so we can get back. And again, we cut out to shorten this whole process, the middle of it, so it's not so slow. So now we're back at the original position we marked. So now in that first try, you notice that we overshot our mark a little bit. The pipe rotated past the center of the torch just a little bit. So we're going to make a small adjustment to the steps branch. I'm going to go up to the config. I'm going to select motor tuning. I'm going to go down to the y-axis right over here. Click on that, and I'm going to make a small adjustment to this steps branch. So I'm going to make this 564 instead of 568. I'm going to click Save Access Settings. It's very important. And I'm going to click OK out of this. Now, this is a very important step. Every time you use the pipe cutter on a different type of pipe, you need to make sure that your steps per inch is set up properly. Otherwise, you won't get the quite the correct distance pipe turning per cut. Now, some cuts you won't notice it as much, but on a fish mouth or a joint cut, it's going to be very important. So click OK out of that. And now we're going to go back and we're going to repeat the same process. I'm going to hold the control button and I'm going to hit the up arrow to start jogging the pipe basically towards me. Now, as you can see, the pipe's rotating a lot quicker this time. That's because I did do the feed rate override and I bumped it up to 300% to speed this process up. So that last time we were right on the mark. It was perfect. If I wasn't right on the mark, I would continue making adjustments to my y-axis steps per inch. So the process is you attempt to rotate the pipe. First, of course, you set up your step motion, which is your circumference of your pipe. You mark your spot, you hit the control button, and use the up arrow to rotate the pipe towards you. If that pipe doesn't rotate the full distance or it rotates too far, your next step is to hit the control button and press the down button. So it will rotate the pipe back to the starting point. Once you're back at the starting point, you then make an adjustment to the motor tuning for your y-axis, either increasing or decreasing this between a couple steps at a time. You'll click Save Access Settings, and then you will hold the control button and use the up arrow to rotate the pipe again towards you, just like we did. And keep repeating that process until you get right on that mark. Until when you hit that control button, you rotate the pipe exactly one rotation. So that's an important process, and it's very important that you get that set up every time that you change the pipe diameter or circumference that you're working with. So I've loaded up a small star cut, and our first thing I want to talk about is doing kind of decorative cuts on the pipe. It's pretty straightforward. Basically, the machine's going to treat the pipe like it's a flat surface. So instead of moving the gantry, it's rotating the pipe. So you don't have to make any real big changes to your cuts. What you do need to do is make sure that the cuts are in the correct order. So if you're trying to cut off say, if I was cutting this star in the pipe and then cutting off a section of the pipe, I'd have to make sure that I cut the star first and then the outside cut and then the inside cut to prevent the inside cut from basically cutting the pipe off before it was finished. So simple little things like that are important. The other thing that's really important when you're working with particularly decorative cuts, really any cut with the pipe cutter, is you have to be very aware of your drops, the parts that fall through the pipe, okay? Because unlike the flat plate, when the pipe rotates around, those parts will have a tendency to fall back out through the cut holes, and they can cause problems. They can cause the pipe to hang up on the pipe cutter support and ruin your cut. So if you're doing a lot of pipe cut, particularly if it's a large cut where you're cutting a large section of the diameter, you got to be aware of what's going to happen to the drop. So in that situation, it's going to be good for you to use your feed hold in between the cuts and to either use some sort of tool to reach into the pipe to pull the drops out, or a magnet or something of that sort to prevent those. That's going to be the safe way to prevent those drops from falling back through the pipe as it rotates and hanging up on it. So the other consideration you're going to want to generally make is you want to cut the pipe as slow as possible to get the best cut quality possible. So I'm going to recommend on thinner gauge pipes that you use a fine cut or 45 amp tips. You're going to want to be able to cut the pipe slower, and you may even want to slow it down a little bit slower than you would normally cut standard plate at. Generally, I find cutting with the torch height control off works pretty much just as well as cutting with the torch height control on when you're cutting a pipe, because the pipe, unless your pipe's not round. If your pipe's not round, you're really going to have a hard time cutting it on this pipe cutter anyway. So provided your pipe's round, whether you have it you're cutting with torch height control or without it, generally you're going to get the same quality of cut. So to prevent hang-ups with the torch height control, generally I like to cut with the torch height control off, but you can cut it with it on. Just make sure your voltage is set for the right speed and the right thickness of material. So now you're going to place your ground on your pipe. It's important that you use the magnet with the lead, because if you try to ground through the bearings, you're going to have shorting and arcing inside the bearings. It will destroy them. So that magnet allows you to place it on the inside of the pipe. For bigger pipe, on smaller pipe, just attach it to the end. So there's our cut. I'm going to rotate the pipe back, and there's the star. Pops right out. So we've talked about doing standard simple cuts on pipe. You really can do any kind of a cut. If you can cut it on a flat sheet, you can cut it on a pipe. This part we're going to be talking about doing specific fish mouths and coping cuts. Now, to generate these cuts, your main objective, is to get the profiles of the cuts. There's a couple ways you can do this. You can do this in a 3D CAD software, or you can do this in a sheet metal unfolding software. If you have your own 3D CAD, you probably already know how to do this. We're not going to cover that in this video. What I am going to talk about is the Sheet Lightning Pro software that we recommend you use with the pipe cutting software. It is the least expensive and most effective way to generate copes and fish mouths for piping. So this software is in addition to the standard software. It costs $200 or $150, but it's well worth it. So when you open up the Sheet Lightning, this is what you're set with. You're going to set your inches, and basically I close this out. The welcome. The first thing you're going to do is open up, and you're going to browse the parametric library designs. Okay. So this is going to show you, first you're going to select on inches, and then you're going to pick the one you want. We're going to look at junctions. Well, not junctions, I'm sorry, T's. And I don't want no offset because I want my pipe to be centered. So no offset. So we're looking at, here we go. I got cylinder, T, angled. You have all types of different designs and different types of cylinders. If you move through, this is also a great sheet metal unfolding software. You know, if you go back to inches, you can set up diverters, of all different shapes and types, and it will unfold and allow you to bend up your part. So, but for starters, we're going to go back to the T's with no offset, and we're going to be working with the cylinder to cylinder T angled. Okay. Once I pull this up, sheet lighting is pretty basic. It all involves clicking on different objects and then pulling up their properties here. So right now I have this part of the T of my intersection selected, and it's showing its diameter, its length, and the seam. So I'm going to change my diameter. I'm working with 3-inch pipe. So I'm going to change my length to 5 inches. As you can see, it's shortened. I'm going to click on my other side, and it pulls up these options. I have object here. I can click on that, and I can also change this to 3 inches. Oh, I didn't change that original one to 3 inches. There we go. So 3 inches, 3 inches. We're going to change that to 5. And I can zoom in here. And then I'm going to click on this link here. So I'm going to want, let's see, 2 on this one. Now, and I'm going to set my, so if I also click on these arrows here, it tells me what I'm looking at. So if I change that angle there, that's that beta. If I go over and click on this angle here, that's this beta. I'm going to change that to 75 for this particular one. So again, it's the same thing. The distance for this object, the distance for this object. Okay? If I click on my distance 1, that shows highlights here. So this is essentially my offsets from the ends where I want my pipe. So if I go into this solid menu, it shows it right here, and I can click and rotate it. One of the things I'm going to want to make an adjustment to here is this a little bit too far here. So I'm going to move that back. So I'm going to swap these. I'm going to make this 3. Let's see how we do there. That's a little bit better. That's more what I'm looking for. So my fish mouth is going to be centered in my pipe, and we're going to cut this coat. And so we're going to cut both of these sections of pipe out of my pipe. So for the most part, it's pretty straightforward. You're just going to want to play around and to determine the correct design. And so there's a lot of features up here, but really these are the ones you really want to deal with right now. So if I click on this, it will unfold these pipes. So the first thing I want to do, if I click on it now and unfold it, as you can see, my fish mouth is a little bit close to this edge. Okay? Still nothing wrong with that, because I have, as long as the seam is not right in the center, if this fish mouth were split on either side of the seam, and what I mean by the seam is this line right here, okay, I can adjust that seam. If I click on this one, I can adjust the seam and rotate it. So I'm sorry, I rotated the seam on this one. I rotated it 90 degrees. I'm going to click on object 1. I'm going to rotate that seam 90 degrees. Let's see how we do. Yeah, so that's even better. It's rotated the seam over here. So if again I go back over it and unfold parts, now it's moved my fish mouth to the middle. Some little tricks that are important. So at this point, I got all my angles set up right. I got my sizes of my pipe set up right. My offsets are all set right. The next step is I'm going to save this. I'm going to export it. I'm going to export it as a DXF file. I'm going to save it to my desktop as So now we're going to close out Sheetcam and we'll open this up in our next software, Inkscape, or I'm sorry, Sheetcam. So here I've taken the DXF that was created by Sheet Lightning and opened it up in the Solid Edge 2D drafting software. This software is included on your machine. If you haven't already watched the tutorial on it, I highly recommend you do, as this video will not be covering all the specifics. So the main thing we want to do with this right now is I need to get rid of all these additional lines. These are all my bend lines, I have my seam lines, and I have a profile. All I want is these black lines on my file. So the first step, as you can see, I have different layers here. So if I hide the seams, those hide. If I click on radial and hide them, it gets rid of that. And so now we're left with these files here. Okay. So if I select these out, okay. If I go up to block, click on this, I can do what's called ungroup, because right now this is one solid line. I can't separate it. What I need to do is get rid of this line right here. Because if I import this line into Sheetcam, Sheetcam will try to cut this line. And I don't want to cut this line. These are the simple, all I want it to do is cut this straight line, and this will cut the pipe off right here. So I'm going to select it and then ungroup. Now that they're ungrouped, I can go in and just select that line. Okay. I can use my cut and cut it out. Same thing down here. Cut it out. Cut. Get rid of it. Cut. So now it's a little bit hard to see, but we have our lines right here. I'll select it so you can easier see it a little bit better. We have our first cut, second cut, third cut, fourth cut, fifth cut right here. So with those changes made, I'm now going to save this file as a DXF again, and so I'm going to save it, DXF, pipe cut 1, yes. So now I've taken my file and opened it up, imported it into Sheetcam. As you can see, the seams and the radials are still there. However, they're all on different layers, so I don't have to cut them. What's important is this profile layer. So if I unselect these other layers, now I'm left with the profile layer, and I've removed the top and bottom parts. That was the whole purpose of using Solid Edge, to make that change. Okay, so now that that's been made, now what I can do is create a cut for this. Okay, so first off, what we're going to want to do is select what type of offset we want. And what I want to do is think about this fish mouth mainly. I want this fish mouth to be an inside offset. Okay, now as you can see, this is red, so this is a closed object. These are white or gray, so those are open lines. Okay, so this is where these functions, offset, open pass, and lead-ins on open pass, comes into play. I'm going to have these two checked. I'm going to select my layer as the profile. Okay, set my arcs, my lead-ins. I'm going to click OK. It's going to generate the cut. Now if I look here, what I see here is I got the inside of my fish mouth, which is good. And now I want to make sure that I'm set up cutting on the correct sides of these lines. So if I look here, If I swap this over to where it's full width, you can see the line right here, so I'm cutting on the correct side of it, because this right here is a piece of pipe, so I want to cut on this side of that line. So if I turn that off, as you can see, I'm cutting on this side of that line, and I'm cutting on this side of this line, and likewise this is going to be a section of pipe here, and I'm cutting on this side of this line and this side of this line. Now, if either one of these were incorrect, let's say for instance this was moved over to the wrong side and I realized that I needed to swap that, the way you do that is you go up to edit your start points, and if you go up here and swap and say switch that to start on the other side of the line with the offset open lines checked right here, offset open paths, when you make that change it will swap to the other side of the line. Now I don't want that because I was in the correct to begin with. What I do need to be really careful of here is the order of my cut. I can't cut this one because right now I'm looking at cutting, let's see, this is our first cut here. That's not going to work. It's going to cut my pipe in half, and then when it goes to make the second pipe cut, there's not going to be any pipe there. So to change this order of cut, I go into my start points again, start points mode. I right click and I can pull up quick cut sequence. Now, if I drag this down, I can decide which is going to be the first cut. So I'm going to make this my first cut. It's going to ask you, do you want to disable the optimization? You say yes. That's my first cut. This is going to be my second cut. This is going to be my third cut, fourth cut, and fifth cut. They're actually already set up the way I want. Now, if at any point in time I realized I screwed up, I can always just type in which cut I want to set next and set it. So, as you can see, we have 1, 2, 3, 4, and 5. That's the order that I want to do these cuts in. So, with that, I can click back out of that mode, and now I'm ready to post-process this. I'm ready to post-process this and save it, and then open it up in Mock and cut it. So I've loaded up my cut that we did in Sheetcam in Mock. Now we're ready to cut it out on the pipe. So the first thing we want to do is zero out our axes. So we're going to jog our axes and make sure that everything is working the way it should be, basically. So if I jog over, I'm going to make sure I have enough room on the pipe to cut out this entire object. Okay, so if I go to a section of pipe and zero out and then jog, if I jog off the pipe and my little crosshairs are still on my part, then I know that I don't have enough material or my pipe isn't adjusted right. You have to take in consideration there's about 11 inches of pipe on the end of the pipe that you cannot cut because the gantry won't reach it. Okay, it will run into its stop. Okay, so you simply have to take that in consideration when making your cut. The other thing you want to take in consideration is where you place your pipe supports. All your pipe supports are adjustable. You're not going to want to put a pipe support directly on a cut like this, okay, because as it spins it will run, the bearings will hit on that and it may knock the pipe off. You're going to want to have a pipe support back here on this side of the cut, and you may want to have a pipe support, say, over in this area. Okay, so you do have to take into consideration, pay attention to where this pipe is supported and where it's going to be cut off and what's going to happen when that pipe rotates. So basically, line up your cut, zero out your axes, make sure you have enough room for your cut, and then you're simply going to make sure you have your correct voltage. Usually, like I said before, I cut with my THC off. So I'm going to hit run, turn the THC off. And here's the final cut. As you can see, it's a nice, clean, tight cut. So, thanks for watching, and that's the basics on how to use the Arclight